Hello everyone, today I'm going to show you a quirk with C++ templates that is legal but can lead to quite misleading code if you're not expecting it, and this is code I've actually seen in the real world, so this is why I'm talking about it today. I've got a brand new project here, I've got my main function generated by Xcode, and we're going to start from scratch. So I'm just going to simplify this main function first, so we'll just use 0 because we don't, rather than using the macro, just make it more explicit. We can get rid of this, and we'll probably just keep the hello world just here. So if we build and run this, we should expect hello world from inner output, and yes, that's what we get, and return 0. Right, so as expected. Now let's introduce our template function. We'll just use a function, won't use classes or anything too fancy. So we will use template, of course, and I like using type name. I know some people prefer using class, but for me I prefer type name, and typically we use the type name T. You see this in the standard template library, for example a vector. T is commonly used. We'll then have to give it a return type. Now I want to return a key, and for this function I'm just going to add 2, so I'm just going to call it add2. Then we will give it some input parameters, and my input parameter I want it to be t, and I'll just call my input parameter input. I won't worry too much about references. I'll just take it pass by copy. It's not a major issue, but you know, if you wanted to do this, say if it was a string, you probably would want to pass it by reference, but it's just we're just going to be probably working with doubles and integers. There's no need, and then we'll get our curly braces to start the function. So I'm going to make it very simple. I'm just going to say I'm going to declare a variable of type t called output, which is equal to the input plus 2, and then we'll return the output. Very simple function. Now if we want to invoke this, we will simply just declare a variable. Let's say we want to use double as our type, and I will call this result, and it is equal to the so add2 function with our input being, I don't know, let's just say 4. Now the problem is we need to actually tell it what type we're going to use, so it's going to be double, of course. And then we'll just we'll get rid of the hello world, and we'll say result is, and then we'll pass the result into this function, into the output stream, sorry, and we will then just flush the buffer. I mean, it's not necessary, but I just like doing that. And let's see what we get. So if you build and run that now, and you can see the result is 6 as expected. Now we can probably change this, so we can actually use int, and then we can just invoke this with an integer instead. We will get the exact same result, right? Because it's an integer or whatever. What happens if I put in 4.3, for example? What would happen there? Let's have a look. And we get 6 still, because it's representing this double as, well, so this is a double, but it's being represented as an int, so we actually lose precision there. We could also use float, obviously, as well, if we really wanted to. 32 bits. And yeah, then we get our 6.3, which is fine. Now, let's just get rid of this for now, and let's just focus on the template type parameter. So typically we use, just get rid of that. We typically use t as our type name template type parameter because it's quite generic. It's what the standard library uses, but we can actually call it anything. We could call it, you know, my type parameter, for example, right? It doesn't really matter. Let's just keep it as t for now, though. But what happens if, for example, we put in a primitive type? So let's say double, for example, and replace everything with double, and this will be a double as well, and this will also be a double. Now what's going on here then? Because you can invoke this with any type, but you've given it the type name double. And you can see here we get an error. It's if we build this, probably won't compile. And yes, we would. It's getting quite confused here. It doesn't quite understand what's going on. We can have a look at the build logs here, and we can see it's expecting qualified name after type name, and it's getting double and doesn't really understand why that is. So let's go back to our code. Obviously, we're not allowed to do this. Which kind of makes sense. You shouldn't be allowed to just call primitive types and redefine them as type names. It doesn't make any sense. So let's go back. Let's say we want it to be called my double, for example. And this is totally legal. We're allowed to do this because my double is just a name. Doesn't really matter. And we can call this my double. This should compile. And does it? And yep. So we got a success, and yeah, we haven't, obviously we've removed it from here. So what we want to do now is, what is my double? Well, what I've seen is, personally I don't really like using this, but let's use typedef. I typically don't like using typedef, but it is what's typically, well, not typically, but sometimes used in real world code, so let's use typedef. So it's going to ask us, what's the existing one? Let's say double. And then we'll typedef it as my double. So my double is effectively, when the compiler runs, it's going to copy wherever it sees my double and replace it with double. Now you're probably wondering, hang on a second, if we are typedefing double as my double, doesn't that make this a double? And yes, you may be right. However, this my double and this my double are actually different. This is shadowed by that. So the internal my double here is actually not a double. It is a type name of the template. In fact, my double could be a string, because if you pass string into your function call, you could get string, but you might be expecting it to be a double. So this is why it's quite confusing, because this is quite a simple piece of code. It's only 20. Well, it's not even that, is it, really? Because it's got some extra stuff at the top. So a few lines of code. Imagine this file is, I don't know, several hundred lines long. And you expect at the top of your file, so you've got your typedef there, and you expect that your double is a double. But you've done this. So this is why it's very dangerous. And I can show you what's going to happen here. So we can totally invoke this. So let's do it the same way. So we do. We're going to call this. So we're going to call this result, and it's equal to the add to function, and the input is going to be let's give it a number 4. Now I was doing template. Let's actually explicitly tell it the template type. And we should need to replace this here. So, and there we go. And we will build and run this again. And again, we get 6. And we can do it with a decimal number, for example. 6.5. Now, you can be careful here, because we can also use my double. It's totally legal, because this is been typedefed up here. And we should get the same result, and we get a build, and we get 6.5 again. So let's just pick a different number so you can see it's actually working, and we get a different result, 6.7. Now this is very confusing here. So we've got our own type called my double, which is replaced, so this becomes double. We then call our templated function with the type parameter double. So it goes into here, replaces my double with double. So everybody see my double, it's going to replace with double. It's fine. But it will get a bit confusing is when we do something like this. Now what's going on here? Now you may always expect this. Let's assume we always think it's a double. So we can add a 2.6. But we've invoked it with an int. So I wonder what the result of this is going to be. As you can see, 6. Now, why has that happened? I thought my double is a double. However, long deep in your code, far down in somewhere, you've you've actually invoked your function with an integer. Remember, you're allowed to invoke these with any valid types, but you thought that this will always be a double because you've written my double. You say, oh, it must be double. So obviously we can go back. You can change this to double again, or let's be different. Let's try float. It won't really matter. Obviously, we're looking at very simple numbers here. There you go, 7.3. So we'll go back to what happens if we invoke it with something that's perhaps not a standard type. And we will include the string header so we can use that. And there we go. Straight away Xcode has said, hang on, you're not allowed to do that. Fine. That's totally fine. And we'll go back to our standard double. So you can see why this is quite misleading. This is why I would recommend that you don't try and avoid typedefs if you can. I mean, there's better ways of doing it. We can use the using keyword instead. So using, it's much better. I tend to just type my types out unless I really need to use typedef, but typedef is pretty much, it's not really the recommended way of doing things anymore in modern C++. So this is using C++ 20, which is the latest version as of this recording. I'd also caution with your template type parameters should be very distinct. You shouldn't be reusing names because it gets quite confusing, as you can see here. If you we can see here, this my double here is actually a double, but the my double here, if we change this, I don't know, float, it's actually a float here. So this my double is a float, but this my double is a double, and you can see it's actually totally illegal. In fact, we can actually check this. Let's put a breakpoint in here and then let's have a look. Let's inspect what the type is. The build has failed because I've got this using here, probably. Let's do that again. And you should pause here. And you can see here, so the output is a float. It's a bit small, but can I make that bigger? Yeah. So this is a float here, despite the fact we have this typedef here, double. So you can see what's happening. This my double is not the same as this my double. This is why we have to be very careful with when we're using typedefs. And I showed you earlier, we're not actually allowed to write double here. So it may look like we're writing double here. It may look like, oh, hang on, you're not allowed to do that. We're actually not. This my double is completely different to this one. This is entirely legal C++, but probably you should try and avoid this. Remember, when you're using templates, you can invoke it with types of your choosing. Now, why would you even want to try and typedef something like a double, for example? Well, for example, if you're working with 64-bit architecture or 32-bit architecture, you may, depending on what you're compiling for, you may want to compile your types that require decimals as a double in 64-bit or a float. So it's an easy way of just translating between float and double. More of a legacy thing, I guess, because most computers these days are 64-bit. So, but maybe you're worried about space, so you may not have enough. You may only have a certain amount of single precision memory on a GPU, for example. So you may want to use floating point numbers rather than double precision numbers. But just be aware of this limitation. Well, it's not even a limitation. In fact, it's a serious issue when someone else comes and looks at your code. Now, your code works fine. It's actually working as intended. You did see a few strange issues here, like if I made this an int, the whole thing doesn't really work anymore. Even though I thought, oh, hang on, I thought my double is a double, but it's not. So you just need to be quite careful with templates and making sure, I think just use a standard sort of format. T is quite commonly used in the standard library. Well, when I break out of this actually, stop. So that's a strange quirk of C++. C++ has a lot of this. Personally, I'm not a massive fan of C++ because of things like this. I think you should not be allowed to be able to do things like this because it can cause a lot of confusion, as I've shown. But it is the language. It is obviously a very old language. It's used in a lot of industries and software. So, and it is getting better with modern C++. With C++ 17 especially, and now 20. There's a lot more features. Classic being unique pointers. Range-based for loops, for example, help with it. But fundamentally, you still have a lot of issues such as memory safety, and so that's my video on what template typedef issue that I've seen, and hopefully you will learn something from this. Please leave a comment. I'm not very familiar with Xcode, so this is my first time using it. I don't really use Xcode. I normally use CLion, but I'm using this on my personal computer today. So I've decided to use Xcode. And this is obviously very simple. In the real world, your functions are going to be far more complicated than this. So thank you for watching.